the next thing we're going to do is very, very similar, but there's just some patterns that you might notice. And that is, so we're just going to look at it the same way. We're going to make our x, what multiplies to 49, and what adds to negative 14. Well, the nice thing about 49 is that there aren't that many factors, so 1 and 49 definitely doesn't work. And they both need to be negative because it adds to a negative, but it multiplies to a positive. And so the nice thing is that there's really only one other pair, and that would be 7 and 7. But if you notice that they repeat each other, so don't ever forget about the numbers that repeat, like 6 and 6, or 5 and 5, in this case it's 7 and 7, because those could be what our factors end up being, and those are ones that slip our minds sometimes. So since it's negative 7 and negative 7, okay, that is just x minus 7 and x minus 7, but you could see that as x minus 7 squared. Okay, squared. So this is usually how we write it in the end when we end up with the same factors. So those create the same factors, and so we just condense it. And when we multiply, remember we said a squared means 2 of them. So since we have 2 of them, we're just writing a square. So the same idea for this one. I know you can't see it here, but you've got it on your page. So what multiplies to 36 and adds to a 12? Well, in this case, they're both positive because it multiplies to a positive and it adds to a positive. So 1 and 36 don't work, 2 and 18, you just go down the line. 4 and 9 don't work, but 6 and 6 do. Again, they repeat each other. So 6 times 6 does give you 36 when you multiply them, but it also gives you 12 when you add them. So our factors are x plus 6, excuse me, it should be a y in this case. Where's my eraser? There it is. Alright, y plus 6 and y plus 6, but a lot of times we condense it to y plus 6 squared. Since we're multiplying the same thing, we're squaring it. Alright? Alright, so why don't you try this one? I won't say anything. I'll just kind of write it down. You can compare to yourself as you go. Again, look for the special relationship. There's a little bit of a pattern in these problems. That one might have been harder to think about if you're not familiar with your factors, so that's why the more you do it, the more you get used to it, the more you'll see it. And I just went ahead and just wrote it squared. Since I saw 2 of them, that means I would write down 2 of them, so I just kind of jumped straight to the squared, since I already knew that that's how it would end up. Alright, so then last one, okay, I put stars by it because you want to look carefully, and we're going to talk about this more in the next couple pages, but this actually has a GCF. If you notice, they all have an X with them, so the very first thing we want to do is divide that GCF out. Alright, so let's divide it out. Divide everything by that X, so it's going to come out front. Then we can factor just like we always have. So when you divide it by that x, you end up with a regular trinomial that we're used to. X squared minus x minus 20. So now we just factor this trinomial. So what multiplies to a negative 20 and adds to a negative 1. So remember, if there's a variable there, it's automatically a 1, and it's negative because of the sign. So we just go through our options, 1 and 20. Okay, they're going to be opposites. One's positive and one's negative because it multiplies to a negative. So 1 and 20 doesn't work. 2 and 10 doesn't work. But 4 and 5 do work. 4 and 5. Double check it. Okay, 4 plus a negative 5 does work. So we don't have to worry about switching the signs. So then our factors are x plus 4 and x minus 5, but don't forget about this factor we did at the very beginning. GCF stands for greatest common factor. So that factor is a part of the answer, and we need to make sure that we include it. We usually just put it out front, because we pulled it out front at the beginning, and then this part broke down into those two. So don't forget that if you do a GCF, which we're going to practice more, that it's going to be a part of the answer. All right?